Good morning, my name is Nycole Davila. I am a student of the Internet of Things here at the Deep Dive Coding Bootcamp. I know your time is valuable. However, before we get started, I'd like to quickly give thanks to the groups that were able to make this possible for me. The New Mexico Information Technology Apprenticeship Program and the Stimulus Center, also powered by CNM Ingenuity. Fuse Makerspace and my teachers, Brian, Tanda, and McCool. None of this would be possible without you guys. I do have a lot to present today, so let's get started. As an artist, I am very much interested in recycling, repurposing, and reusing different objects to create something new. I was able to get an old menu from an ice cream shop and had the idea to turn it into a custom art clock. What I was able to do first in this process is that I removed all the old lighting technology from the unit. After that was completed, I scraped off all the sticker lettering on the plexiglass. I cleaned it, I sanded it down to create a surface for the painting. I used Create Text colors and hand-painted a New Mexico scene of the Sandia Mountains onto the plexiglass. I was sure to use a mixture of transparent and opaque colors to create an environment that was clear and vibrant, but also allowed colors to be seen from behind. Once that was done, I created a center panel and mounted strips of NeoPixels that would be controlled by a Arduino Teensy, a clock, and a photodiode. I was able to get a custom control panel made thanks to Tanda to mount onto the side to give the user control from the outside. Once the control panel was retrofitted into the unit, I repainted the unit and gave it a protective coating on top of that. Once that was completed, I reassembled the unit and the installation was complete. The programming of the unit allows a few different settings. A clock setting, both settings for daylight savings on and off. There is a morning setting, an afternoon setting, a sunset setting, and a night setting. There is a clock setting that changes the colors through morning, afternoon, sunset, and night. These settings are also standalone options in the menu, and there is a photodiode setting that will change the colors in correspondence to the immersive light in the room. To protect the microcontroller, I 3D printed a protective case that was also installed on the opposite side of the center panel. As my capstone project, I decided to create a warning system for the Arroyos during a flash flood or other environmental situations. Being born and raised in New Mexico, I was taught from a very early age that the Arroyos could be very deadly and the conditions within them could change very, very suddenly. To start my project, I took a 4-inch PVC pipe and split it in two, sealing it with screws and silicone. I took recycled metal hangers for various supports. I took LED lights, resistors, and other items to create a daisy chain of LED lights that were used to create a lighting pattern down the channel. For the first sensor system, I took a moisture sensor, RBG diode, and vibration sensor to create a flash flood and earthquake warning system. These items were mounted to the system using duct tape and glue. The next set of sensors implemented was a BME 280, buzzard, SD card and reader, breadboard power supply, and relay. What this allowed me to complete was a weather monitoring system with an audio output and a system to record the data for any environmental changes. The BME 280 weather sensor and buzzer was mounted to the top of the Arroyo system. Here is a demonstration of the flash flood warning. This is the information that is recorded to the SD card in association to a simulated flash flood. Next is a demonstration of the earthquake warning system. This is the information that's recorded to the SD card in association to an earthquake simulation. For the final sensor system, I took magnets, L brackets, servo motors, and a Hall effect sensor to create a diversion channel. Using recycled plastic, I created a spinning device and mounted the L brackets and magnets onto it at two opposite points. Over the top of the device, I mounted the Hall effect sensor. As the device spins, the sensor will pick up the movement and count the rotations around. Further down the Arroyo channel, diversion pipeways were created. They have slots carved into them so that a doorway can be opened and closed by a servo motor. The motor was mounted to the pipe and secured with duct tape. A custom doorway was carved out from recycled plastic and attached to the servo motor using screws. A piece of recycled foam was used to insulate the inside of the pipe to prevent excess water flow. The concept idea here is, depending on how fast water is going through the channel and spinning the magnetic device, the Hall sensor will record that movement and trigger the servo motor so that water can be diverted elsewhere. In conclusion, with all of these sensor systems in place, a warning system could be created that would monitor the weather, record that data, and with online capabilities, be monitored remotely. With this information, people could be warned via text message and with audio and visual outputs. But most importantly, lives would be saved when extreme weather hits. Thank you very much for allowing me to show you the projects that I was able to complete during this course. If you would like to see further information, you can go to my website, NycoleDavila.com. Thank you very much for your time. Please stay safe.